Okay, folks, we have some more related rates problems coming up. And these problems are all going to deal with triangles. So we have a right triangle in this problem. We're still setting up an equation and taking its derivative with respect to time. We're following those same 4 steps as before. And in fact, this first problem is going to look a lot like our rectangle problem from the last one. And then we'll switch it up for our second example and use another formula that you're very familiar with involving triangles. So the text says a right triangle has legs of 18 inches and 24 inches whose sides are changing. The short leg is decreasing by 4 inches per second. The long leg is growing at 2 inches per second. Okay, so it's going to be trickier in this one because it's just to keep these legs straight, I think. So we'll say the short leg is 18. The long leg is 24. The legs are the sides that are not the hypotenuse of a right triangle, right? So our first step was to sketch, remember? Our second step is going to be to write an equation. So what we want here is an equation that gets us to the question it's asking. What is the rate of change of the area? So area is, for a triangle, 1/2 base height. Right? So there's our equation. And remember, we're going to treat this as a function of time. So all 3 of these variables are changing as time goes on. So our short leg is shrinking, our long leg is growing, and our area is changing in some way that we're not quite sure about yet. So you can imagine this triangle kind of stretching out and shrinking over time. We want the rate of change of the area. We're going to take the whole derivative of the whole thing with respect to time. dA dt is the change in area with respect to time. This is our third step, by the way, is the derivative. And then 1/2 I'm going to factor out, actually. I think is the easiest way to tackle this. And then we have base times height, but these are both functions. We're going to do product rule. So b times dh dt plus h times db dt. So product rule there. And here is our equation that relates the rate of change of the area to the rate of change of both the sides. Right? And by the way, let's call our height 24 and our base 18 like that. Okay. So then we're just going to substitute based on what it says in the text. So 1/2 times b is 18. The change in height with respect to time. So height is my longer side, and it says the long leg is growing at 2 inches per second. So growing is positive, 2 inches per second is just 2, it's constant. Then h, 24, so that's the height of my triangle, plus how fast the base is changing. So it says the short leg is decreasing by 4 inches per second. So -4 is my derivative there. Okay, so I've substituted and solved as my last step. So here, I am just going to simplify this. So what do we get here? 36. Next term is going to be negative. And 4 times 24 is what, 96? 1/2 is still chilling. 36 minus 96 is -60. So this ends up being -30. And you may be thinking, like, can this be negative? Which is a good question because we're talking about lengths here. But remember, this is the change in area over time. -30. And what's our units? Inches? Inches per second. Square inches per second because it's area. So what this means is that our triangle is shrinking, or our area is shrinking. So yes, these can be negative. Okay. So that was just like our rectangles problem. Now let's try one that's a little bit different. And this is going to be a very familiar triangle formula for you guys. A very similar setup. So we have legs of 24 inches and 32 inches whose sides are changing. The short leg is decreasing by 4 inches per second. The long leg is shrinking at 4 inches per second. What is the rate of change of the hypotenuse? So that word hypotenuse should make you think something here. Before we think too hard about that, let's draw our sketch. So we have a right triangle again. And what do we know? So we have a 24-inch leg and a 32-inch leg. And then our short leg is decreasing by 4 inches per second. Let's make a note of that in our picture. That might be helpful. So by 4 inches per second. And our long leg is shrinking at 4 inches per second. So our derivatives are actually the same. Okay. Now, what is the rate of change of hypotenuse? So we sketched. We want our equation now. So I bet you're thinking what I'm thinking, which is hypotenuse. So that means I use Pythagorean theorem, right? A squared plus b squared equals c squared. Totally. So now, this is a little trickier because of all of these exponents in here. So here's where chain rule becomes very important. To start, so I don't get confused, just label my sides. So let's make A my short side and B my long side. It does not matter, but let's label them so we know. And then C is obviously the hypotenuse. We're going to take the derivative. And remember, A is a function of time, B is a function of time, C is a function of time. So as I take my derivative, I go straight across. 2A is the derivative of A squared times the derivative of A with respect to time. So chain rule right there, right? That's what I mean when I keep saying chain rule is important for these. Same thing here. Derivative of B is 2B dB dt equals, same thing over here, 2C dC dt. Okay. Now, this is where these get cool. So, I need to make these substitutions. And I know A is 24, so 2 times 24 plus dA, or times dA dt. dA dt is negative 4. So the short leg is decreasing by 4 inches per second. Plus 2 times B is 32. dB dt, which is negative 4 also, equals 2C. And I'm pausing. You should be pausing too, because we don't know what C is, right? So we'll leave C alone for now. And we'll say dC dt. Remember, that's what we're trying to solve ultimately, is the rate of change of the hypotenuse. Okay. So now we have a problem because we have this whole setup, but we have a variable we don't know. I guess I can simplify this sum. That might be helpful to me, right? So 2 times 24 times negative 4. It's going to give me negative 192, and you can do that on your calculator, of course. Over here, I'm going to get negative 256 equals 2C dC dt. Okay. And let's combine like terms. I get negative 448 equals 2C dC dt. Okay. And you're like, still not there, right? Well, you guys already know how to figure out what C is. You have known since 10th grade, probably earlier, probably since middle school. And it's this, right? So A squared plus B squared equals C squared. That's still a useful equation to us. We know A and B, so we can solve for C. So sometimes when you make these substitutions, you have to solve for some of the variables. And that's where these start to get harder. So 24 squared, A, plus 32 squared equals C squared. And then that gives me C equals 40 when I solve that. I'm going to trust you guys know how to solve that. So C equals 40, I plug that in. This is where these get really fun. So I plug that in. 2 times 40 is 80 dC dt. And then I'm almost done, right? So now I just have to solve. So I divide by 80 on both sides. And I get dC dt is isolated. That's what I want. Equals negative 5.6 is what I get when I divide that out. Inches per second. Okay, so there is my solution. Okay, so this one got quite a bit harder in this step. We had to make this whole other step of figuring out what one of our variables was. Okay, so make sure you capture this example down and refer to it back as you're solving these problems.